Advent of Code, Day 8. Oh, okay. Wow, that took me too long to parse. So we have yeah. Mm-hmm. Now, so that constructs that. Three largest circuits. Uh, sure. Yeah. Mm-hmm. Make a circuit. Yeah. Mm. Just for paranoia's sake. Yep. Where am I calling there? 8. That seems way too small. That's bad. Okay. And shouldn't do anything. What? Oh, wait a moment. We're doing a Euclidean distance. Oh, we're not. Oh, okay. That's the wrong distance formula. That would, of course, change things. So D equals. I don't think I need that. Yeah. Correct. Oh. Hey. I am fundamentally doing this wrong. I see. Um, okay. Yeah, I'm just doing this wrong. Right. Distance will still be that. Which guarantees that won't happen. Yep, then. Yeah, we'll do that. Oh, right. Enumerate. Five, 4, 2, 40. Okay, there we go. Reading comprehension is important. 1,000. Why am I printing so much? That's why I'm printing so much. Okay, that could have been better. Until they're in one large circuit. Okay, okay. Um, ugh. Yeah, there are smarter ways to do this. I'm gonna do the dumb way. Um, don't even necessarily need that. I don't. I don't. Yep, we'll do that. You'll move earlier. I was afraid of that. Okay. Yeah, that could have been better. I definitely was not in the top 100 today. Yeah. Um, so I got reading comprehension today, but got the answer, which is good. So yeah. Um, I'm definitely going to want to improve both of these solutions. First solution's actually pretty efficient in the end. I could have definitely done better had I read. So fundamentally, what we're trying to do is uh, every every junction box here has a distance to all the other junction boxes, and we can. It's wanting to deal with the straight line distance. If you wanted the real straight line distance, you would need to do the square root of the sum of the squares of the distances in all the directions. I have a hunch that that probably would come out to an integer, just because I know Eric likes avoiding doing anything that requires floating point math. But I'm not entirely sure. And maybe all the floating point numbers, if you do the square root, actually work out cleanly. But ultimately, we don't even need the true straight line distance. We just need to be able to compare the straight line distances. And lucky for us, as numbers go up, the square of that number also goes up. So we don't need the true straight line distance here. We can just take the sum of the squares uh, of the, or yeah, the sum of the squares of the three coordinates, x, y, and z, those distances, and that's good enough for comparison's sake. So we can get all that for all the pairs of coordinates. That's what I'm doing here, and sort that. And at that point, we just have a sequence of distances between junctions. And once we have those distances, we can connect those up in a graph and just do some simple graph traversal to find what the clusters are in that graph. Find which circuits are now there in our connected graph. Take that list of circuits, go and sort them together based on their length, and our last three are going to be our biggest. Multiply those lengths together, that'll get us our answer. So yeah, part one, uh, somewhat involved, multi-step problem for part one, but not too bad. At least not too bad when you read the problem and do it correctly. I got tripped up because I was thinking we were just taking each junction and connecting it to its nearest neighbor and calling it a day, which gave me a whole bunch of length 2 circuits. Definitely not what we want. So yeah, when you do the right problem, you get a better answer. Go figure. For part 2, uh, we no longer know how many we want to connect. We want to just keep connecting until they're in one large circuit. Now, the smart way to do this, which would have taken more time to code and which I'll probably go back and do because it's going to run faster, is to keep a running tally of the circuits. And whenever you go and connect to two junction boxes that are not part of the same circuit, go and merge those circuits together. That is definitely something that is doable. I just I'm going and doing this for speed, so uh, I don't want the pretty solution yet. I'll do that later. The really dumb solution is just take that circuit handling code we had from part one, uh, modify it a little bit to just check, hey, is everything in one massive circuit? Which in part one, we had to go through when we're making the circuits, go through and handle every individual junction box because they could be in different circuits. Uh, do this loop here, do a make circuit on every single starting point, and see what all circuits we get out. In part two, since we just want to make sure it's all connected, we can start on the first junction box and just stop there. Because either it contains everything or we're not finished. So if it contains everything, uh, then our handled set, which I didn't actually call out in part one, but we do need a handled set just to make sure that make circuit doesn't loop forever. So as we're handling something, as we're making the circuit, if we've already handled it, we don't need to handle it a second time. It's already in the circuit, we're already good. Uh, in part two, just pretty much the same thing. As we're making the circuit, we check if it's handled. So we return. If not, add it to handled. And if we've handled everything, that circuit that we're trying to check from the first junction box is everything. It's the full circuit. We are done. So yeah, if that contains everything, we're done. And we just loop over all the potential connection points until we finally have a connected circuit and we have our answer. Now here, this took me somewhere between 6,400 and 6,500 checks to do. So the actual connection in the graph is not the expensive part. Checking if it's fully connected is 100% the slow part here. It's why this was chugging along. I was getting a little worried at how far this was going, but thankfully we did connect after not too long, got our answer, and we're good. So yeah, I definitely already said it twice. I'll say it again. I got reading comprehension here. It happens in Advent of Code, but got the right answer. So that's good. And I'll be back tomorrow. I'm actually wondering at one point when we were making this graph here, I was somewhat hopeful we were going to get some sort of shortest path algorithm or shortest path question so I could break out Dijkstra. Couldn't break that out yet. So I'm wondering when that's going to come up this year. We only have 4 days left. So yeah, might be soon, might not be. I guess I will see tomorrow. But yep, that's all I got for today.